All right, let's look at some of these. We only have a half hour. I have 2 documents, and one of them has a problem on it that's like a 15-minute problem. So
Okay.
you may have to direct
Alright.
where you want, which problems you want to work. Have you worked on any of these?
I haven't. Some of these are a bit confusing. I'd just like to go over a couple of them,
Okay.
if that's okay.
Which one would you like to start with?
Um, how long do you think it'll take to just do these 4?
Let's try.
Okay.
All right. These are all perpendicular,
Mhm.
and DA is parallel to BC.
Mhm.
And DA is congruent to BC.
Mhm.
Okay. And they're asking us about triangle ADE, this triangle right here.
Mhm.
Which one are we going to prove that it's congruent with? Just looking at the picture.
BFC.
Yeah, I mean, clearly there's no way that it's congruent to that one. So
Yeah.
these are the 2 triangles that we care about. Okay, let's start with DA equals BC. So if I draw one of these triangles, and frequently I do find it helpful to just draw one only. In other words, that side is congruent, or we'll draw it, but in a different, not in this context. So that side is congruent to that side. What else do we know? Based on perpendicularity.
Okay.
Means that's a
A.
right angle, and that's a right angle. So those are equal.
Mhm.
So that's equal to that. So we only need a third piece of information. It must come from the fact that DA is parallel to BC.
Mhm.
Because if we look at the diagram, there's DA, there's BC, they're parallel, and there is a transversal, AC. That means what?
Mm.
In my picture here, well, let's see. We can't even do it like that. Let's see. I need the fact that AD is parallel with BC means what about that angle and that angle?
That they're congruent?
Yeah. Always remember one thing about parallel lines, and this is all you really have to remember. When you cut a parallel lines with a transversal, all acute angles are equal to one another, all obtuse angles are equal to one another. So that one's an acute angle, that's got to be equal to that one.
Okay.
This one's an obtuse angle, it's got to be equal to this one, and this one, and this one. In other words, even though you create 8 angles, you only have 2 unique angles, and furthermore, they're supplementary. They always add to 180. So going back to our picture, that angle is equal to that angle. Notice that's the transversal.
Mhm.
There's the acute angle, acute angle. So, and what that means for our picture is that that angle is equal to that angle. And
Okay.
let me use the double thing. Okay, now looking at one triangle only, that one right there, is it congruent? There's 3 pieces of information. If it's congruent, what would it be based on?
Would it be Side angle angle?
Side, yeah. Side angle angle, which is the same thing as angle angle side.
Okay.
In other words, I can put these in either order and go from left to right or right to left, and you get the same thing. But yeah, in other words, it's got to be angle, angle, side, not angle, side, angle. And I'm not sure how I know not to go counterclockwise here. I guess that if you try to figure out whether to go clockwise or counterclockwise here, notice that the closest, you'll have to take the fewest number of steps if you go clockwise.
Okay.
And you'll have 1 step, 2 steps, 3 steps. Angle, angle, side. Or even if I start here, I'll have side, angle, angle. But notice that if I go the wrong direction, I got more than that many steps. I've got 1 step, 2 steps, 3 steps, 4 steps. And I'm even skipping a few sides there. So you always go in the direction that is the shortest, basically.
Okay.
And so, okay, so we've done 23. Let's have a look at 24. Try to draw this real quickly. Frequently, the secret on these is being able to picture it separate from the figure. You know what I mean? In other words, being able to see 2 triangles here instead of this weird shaped 1, 2, 3, 4, 5-sided figure. They're saying that CR is equal to WO, so I'm just going to put it like that. CO is equal to WR, so I'm going to do that, and I mean the whole line, not just that piece of it. In other words, CO is equal to RW, okay? Interesting. COR, in other words, this triangle, COR, is they're trying to prove that it's congruent to this triangle. We have 2 pieces of information, right? We need a third. Well, I see a couple of additional possible pieces of information. What are they? There's this angle. That's equal to that angle because they're vertical angles. That's 3 pieces of information, but does that prove congruency?
No.
No, because that's side, side, angle, or angle, side, side. That does not prove congruency. So where's another third piece of information? RO is equal to itself.
Yeah.
In other words, there's the third side. So these 2 triangles are congruent based on which theorem?
Side, side, side.
Side, side, side. That's actually the easiest one. Okay. That's why you don't see it very often. Right?
Yeah.
I haven't seen very many side, side, sides. That's maybe the first one I've seen. Okay, SA, the base is parallel to the top, and EN is parallel, excuse me, the sides are parallel and the tops are parallel.
Yeah.
And they're trying to get us to prove that that is similar to that, or congruent to that. So, how are we going to show that? Here, let me draw it. And the way to do this with parallel is to use one set of arrows there, one there, showing those two are parallel, and two sets of arrows here, and that shows that these two are parallel. And that is a transversal. So what does that mean? Always know that when they tell you that two lines are parallel to one another, there is almost always, 100% of the time, some transversal between them.
Yeah.
And this one happens to be a transversal not only between these two parallel lines, but also between these two parallel lines. The same line is a transversal for both sets of parallel lines. So if I'm going to number the angles here, I want you to tell me which angles are equal to one another, based on the parallel lines and the transversal.
1 and 4 are parallel.
No, they're not really with that transversal. In other words, I don't know that 1 is equal to 4. The picture you have to look at is if I have two parallel lines and a transversal, is you have to look at those 8 angles. Okay, notice that 1 and 4 are not in this picture.
Okay.
Okay, 2, 3, 5, and 6 are. Which ones are equal to one another? If I
5 and
go ahead.
2.
5 and 2, exactly. 5 is equal to 2 because they're alternate interior lines based on the top and bottom parallel lines. What else? If I rotate the picture and look at it, rotate it 90 degrees to the left, which other two angles are equal?
6 and 3.
Yeah. Those are also alternate exterior or interior lines, but in this case, it's based on the other sets of parallel lines. However, that's 2 pieces of information, right?
Yeah.
What's the third piece? Knowing that we have an angle and an angle, what does the third piece have to be? Can it be an angle?
No.
It's got to be a side.
Yeah.
So which side is?
The transversal line going through the middle?
The side that is common to both triangles. This side right there. And now, separate and look at one triangle only. Don't try to figure out which angle. In other words, don't try to figure out the corresponding parts. Just look at this triangle. What is it? What's the rule?
Angle, side angle?
Yeah, you got it. You know how to put them in order now. And those are the 3 closest. In other words, I wouldn't go in the long direction. I would go in this direction. Okay. Well, we're definitely going to be able to get done with these 4 problems, at least. Again, notice the side that is common to both triangles you can bet anything that we're going to need that. Let's just put a hash mark through it. It's the same with both triangles. Okay, ABD, ABD. This angle is similar to CBD, that one. ADB, this angle, is similar to CBD. I got it backwards. Did I get that right? ABD is similar to CDB. Okay, this one is congruent to this one down here, and this one is congruent to that one up there.
Okay.
Are these congruent triangles, and why?
Okay, well, we only have 2 pieces of information.
But we have that middle piece. In other words,
Yeah.
we have the line that's common to both. So that's our third piece.
Okay.
Okay. So what is it? What 3 letters in what sequence?
Angle, side, angle?
Correct. Again, you go the quickest way, which is to go clockwise, starting with the end point. You get angle, side, angle. Again, eliminate this triangle from your view. If you have to, redraw the one on the left so that it's the only one you're looking at, and you know that, you know that, and you know that. It's not important that that is congruent to the bottom one over here. Doesn't matter. It's just however order those are in right there.
Okay.
Let's see. That's everything on that page. And I think this is the other one. Correct? No? Yes?
No.
No?
Mm-mm.
Wrong one up. It was this one.
Yes.
All right. You're in honors geometry?
No, I'm just in regular geometry.
Really? Okay. I thought this problem was for honors only.
I don't know.
Well, we have 10 minutes.
Okay.
I don't know that we can spell out everything in 10 minutes, but I can certainly give you the principles.
Okay.
Okay? And the number one principle, in fact, I would have to redraw this if I were actually going to solve for every letter. It's the only way I can do it. But if you have this piece of paper in front of you, I will tell you how we get the answers to these and just write in there, okay?
Okay.
And then, okay, the first secret is you don't have to start from A. We can't necessarily solve A immediately. So you start with whatever you see you can start with, and then you kind of move around. Can we solve for, let's start from the top and move down. Can we solve for I?
Yes.
What is it?
52?
Okay, can we solve for K?
Yes.
What is it?
The same, it's 52.
Okay, go ahead and fill those in. That's based on those 2 parallel lines and that transversal. You with me?
Yeah.
So that's 52, and we know that this angle on the lower left is equal to this angle on the lower right. What must those be if that's, in other words, they're telling us that's an isosceles triangle, the big triangle.
Yeah.
We know that side's equal to that side, but mainly we know this angle is equal to that angle. Now, what do they have to be if this one's 52?
Wouldn't it just be the same?
No. In other words, the sum of these 3 angles has to be what? What's the magic number in geometry?
Oh, it has to be the same. Okay.
Well, first of all, the sum of the 3 angles have to be what?
180.
Okay. We know this one's 52, and this one is the same as that one. So how are we going to figure out what these are?
Subtracting 52 from 180.
Okay, you get 128, and then what?
And then, don't you divide by 2?
Yeah, in other words, both of these have to be 64 degrees because they're equal. And
Okay.
only 64 works. 64, 64, and 52 make up the magic number 180.
Yeah.
So, now that we've solved for this angle and this angle, we can solve for A. We have the exact same situation with A. We know we're looking at an isosceles triangle. We know the vertex angle, that being the angle that's not the two base angles.
Yeah.
Notice that in this little triangle here, the two base angles are that one and that one. That one's 64. What are these two?
52.
64 is 116. Did I do my math wrong?
No, that's not right.
1/2 of 116. 58.
Okay.
Okay. So A is 58, and label that one 58. In other words, that's the way you solve these. That you just kind of make your way through the triangle, labeling everything you can figure out, and eventually you know everything, all the numbers. Now, what's B if this one's 58?
122.
Okay, good. In fact, let's see. What is F? Based on the fact that this line is parallel with this line. And that is transversal right there.
It would be 58.
Same as A, right? Yeah, in other words, A is the corresponding angle to F based on the parallel lines and the transversal. So we know that one, and now we know this one. Let's see, we know this one over here. We know F. What about H and J? Based on that parallel line, and this transversal.
Would J be 128?
Well, it's the same as H.
Okay.
And it's not the same as that. However, let's see. The problem with me doing it this way is I then don't have the whole thing labeled out. And without seeing what I've already written for answers, it's hard for me to figure out the rest of it. I remember J is equal to H. Let's see, we know that. We know F. We know G. What is G? G is the same as this one right here. They're also a linear pair. If they're the same and they are also a linear pair, what must they be?
90?
Yeah. In other words, a linear pair is any time you have a straight line and another line that intersects with it. Well, 1 and 2 are always supplementary. So we know that that one is supplementary to that one, and they're telling us they're equal, so they're both 90.
Okay.
What is this entire angle right there? Based on this parallel line, and this transversal.
I'm not sure.
What did we have for B?
122.
That's the same angle. They're corresponding angles.
So they have to equal 122.
The total does. And they're also equal. So what's each one equal to?
61?
Correct. 61, 61. This one, we had this one, right? L? That was supplementary to B, based on those two parallel lines and that transversal. That's the acute angle. That's the obtuse angle. So we know L, we know C, we know F, we know this one's 90. Now we know E. What is E?
Okay, is it 29?
Yep. We knew F, we know E. What's the relationship between F, E, and D? They're supplementary.
They equal, yeah.
It's not a linear pair, but there's three angles that make up the straight line. The one thing we know is that's always 180 degrees. I don't care how many angles make it up. Okay, so F plus E plus D equals 180, which allows you to figure out D. And that's the last thing we need to know. We know everything else.
D is 93.
Okay, so there was only three principles involved in figuring all of this out. Number one was parallel lines and transversals. Okay?
Mm-hmm.
Number two was isosceles triangles, where if you know the vertex, you can figure out the two bases. Or in fact, if you know it's isosceles and you know any angle, you can figure out all three. And linear pairs have to add to 180.
Mm-hmm.
That's the only three principles we needed to figure out all of these letters. Wow, it only took 10 minutes. Almost easier. Well, I had done it once. I had done it, and the first time I did it with the student, I had to draw it all out. And as we figured them out, I had to label it. And then I could figure them all out. But so, all right. Good to go?
Yeah, thank you.
All right, Kendall. Have a good one.
You too.
Bye-bye.